The star Betelgeuse, a red, extremely gigantic beast tracked down in the great assemblage of Orion, has long enchanted stargazers and cosmologists alike due to its sheer size and splendor. If Betelgeuse were set where our Sun is, it would stretch out to the orbit of Jupiter, asserting its monstrous size. Regardless of being situated around 642 light-years from Earth, its colossal size makes it quite possibly one of the brightest stars visible to the naked eye. Moreover, Betelgeuse has shown peculiar behavior, such as astonishing dimming and brightening cycles, which many experts believe signal that the star is nearing the end of its life. The famous physicist Brian Cox recently made a bold statement that Betelgeuse is on the verge of a catastrophic explosion expected to occur within the next 14 days. This event, known as a supernova, will mark the end of Betelgeuse's life, but will provide an extraordinary opportunity for experts to study one of the most astounding and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for decades, but its recent unusual brightness fluctuations have sparked speculation that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, leading to a massive explosion that releases a tremendous amount of energy, radiation, and cosmic material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a specific kind of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would typically be devastating if it occurred near Earth, Betelgeuse's distance of around 642 light-years means that, although the explosion will be visible and dramatic, it will not pose any threat to life on our planet. However, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will emit over its entire lifetime. Betelgeuse's explosion won't just be an awe-inspiring cosmic display, but also a significant moment for science. Scientists are eager to observe this rare event from its earliest stages using various ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most critical aspects of the supernova will be the burst of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can reach Earth before the light from the explosion due to their ability to pass through almost everything without being affected. Observatories like Japan's Super-Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in observing Betelgeuse's final moments. The explosion will also offer vital insights into the creation of heavy elements. When stars explode, they produce and distribute elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova isn't expected to harm Earth, it will interact with our planet's atmosphere and magnetic field in captivating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. Although these cosmic rays might temporarily affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and short-lived. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will captivate not only the scientific community but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Researchers have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds urgency to these observations. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be pivotal in potentially altering our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique chance to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the scale of the universe. The event will also provide a once-in-a-lifetime opportunity to investigate dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could offer indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of elements essential for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living organisms. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and dispersed. The cultural significance of Betelgeuse's explosion is also profound. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will provoke philosophical reflection on the transient nature of the universe. In some cultures, such celestial events have been interpreted as signs or omens of great change. Betelgeuse's explosion might inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This spectacular event is likely to reignite interest in space exploration and astronomy, drawing more people into the quest for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and documenting the same cosmic phenomenon from their unique vantage points. Betelgeuse's explosion is not just a colossal cosmic event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity seeks to extend its presence in the solar system and beyond. Furthermore, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are essential for spreading the elements needed for life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how the building blocks of life might spread to other planetary systems and potentially spark life elsewhere in the universe. The impending explosion of Betelgeuse, one of the most visible stars in the night sky, is set to be one of the most significant astronomical events in recent memory. Its supernova will provide a wealth of scientific data, enhance our understanding of the universe, and undoubtedly captivate people around the world. Betelgeuse's death will mark the end of a massive star but also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces bursts into view. For scientists and stargazers alike, Betelgeuse's final journey will be awe-inspiring. As Betelgeuse approaches the final stage of its life, one of the more speculative yet intriguing possibilities associated with its impending explosion is shedding light on some of the universe's greatest mysteries: dark matter and dark energy. These enigmatic forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some theorize that supernovae, like the one expected from Betelgeuse, could hold the key to unlocking some of these mysteries. Supernovae release vast amounts of energy and radiation, and some scientists believe these powerful forces might interact with dark matter in ways we can observe and study. One compelling hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, Their interaction with the energy released by Betelgeuse's supernova could provide clues to their nature. Such a discovery would offer the first direct evidence of dark matter, a phenomenon that has baffled scientists for decades. Additionally, there is potential for Betelgeuse's explosion to offer insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the most critical challenges in modern physics. Betelgeuse's explosion might provide indirect evidence of dark energy's influence on stellar death, as supernovae are thought to be affected by the universe's expansion. Even if Betelgeuse's supernova does not unlock these fundamental mysteries, it will undoubtedly be an event of cosmic proportions. As Betelgeuse reaches the end of its life and explodes, it will offer a rare opportunity for scientists to study some of the most profound and mysterious aspects of our universe. Regardless of its specific outcomes, the death of this massive star will undoubtedly go down in history as a monumental moment in our quest to understand the universe.